This video covers Spelman's homework for report period 3, week 5. It'll cover Monday, Tuesday, and Wednesday, so if you need to get straight to one of those days, you'll have to fast forward through the video. Let's start with Monday. Solon and Tara are in 6th grade and both take dance lessons at Twinkle Toes Dance Studio. This is Solon's first year, while this is Taryn's 5th year of dance lessons. Both girls plan to continue taking lessons throughout high school. I know that Solon started 4 years after Tara because during Tara's 5th year, it was Solon's first year. That means that during their 6th grade year, which is when they both started dancing, because we know they're currently in 6th grade, during their 6th grade year, Solon has 0 years of experience dancing, and Tara has 4 years of experience dancing. Now, if you instead of putting 0 and 4, put a 1 and a 5, that would also work. It would depend on whether you interpret this table to mean the beginning of 6th grade or the end of 6th grade. I'm going to stick with 0 and 4, but either way works, and it won't change your answer to question B. I know that after 1 more year, Solon has 1 more year of experience, and Tara has 1 more year of experience. So both their years of experience simply increase by 1. We can continue that pattern through the table. During every year, they gain 1 year of experience because they keep dancing. And eventually, our table will look something like this. That was question A. It just asked us to complete the table. Question B says, if Solon has been taking dance lessons for Y years, how many years has Tara been taking dance lessons? In this question, you're being asked to identify the pattern that takes you from Solon to Tara. You know you're moving in this direction in the table because they define Y as the number of years that Solon has been taking dance lessons. I know that no matter what number is in Solon's column, I can always do the same thing to find Tara's year of experience, and that is add 4. 0 plus 4 is 4, 1 plus 4 is 5, and so on. We can continue this all the way down the table until we see that if Solon has Y years of experience, Tara will have Y plus 4. And that just means that Y could be any number of years of experience Solon has, but we can always add 4 to find the years of experience that Taryn has. Let's take a look at question 2. In question 2, we have a similar setup, where we're being asked to organize a real-world situation into a table. Question 2 says, Dayjoy and Damien collect fossils. Before they went on a fossil hunting trip, Dayjoy had 25 fossils in her collection, and Damien had 16 fossils in his collection. On a 10-day fossil hunting trip, they each collected 2 fossils each day. A. Make a table showing how many fossils each person had in their collection at the end of each day. Well, we know that the first thing any table needs is labels. And this skinny column here is going to tell us what day it is. We need 1 column for Dayjoy and 1 column for Damien. But we need a little bit more than that because we want to identify what the column is counting. I know that both columns are counting how many fossils we have. It's always helpful to be as specific as possible. And they go on this hunting trip for 10 days. So I wrote 10 days. Now, I know that on day 1, both Dayjoy and Damien collected 2 fossils. But I also know that they started with a certain number of fossils. So in fact, let me adjust my table and add day 0. And day 0 would just represent before they even go on the trip. Before they even go on the trip, I know that Dayjoy had 25 fossils in her collection. And I know that Damien had 16. Then on day 1 of the trip, both of them get 2 new fossils. So Dayjoy ends up with 27, that's 2 new fossils, and Damien ends up with 18, that's 2 new fossils. And we can continue this pattern down the table, adding 2 on each day, because for each day of the trip, they collect 2 more fossils. We can do the same exact thing for Damien. So you notice that the pattern moving down the table is +2. And the reason is because every day of the trip, both people get 2 fossils. But question B asks us to identify a different pattern. It says, if this pattern of fossil finding continues, how many fossils does Damien have when Dayjoy has F fossils? So we know this column is Dayjoy. And what they're asking us is, for any number of Dayjoy's fossils, how can we use that information to find out how many Damien has? So if I have an F in the table, I'm going to put it right here at the bottom, squeeze it in, an F, what can I always do to F to find out how many fossils Damien has? And we can see the pattern in the table the same way as before. This time, we're subtracting 9. And I could go all the way down the table, subtracting 9, subtracting 9, subtracting 9. And I know that for F, any number of fossils, F minus 9 will tell me how many fossils Dayjoy has. And so since I can always subtract 9, in question C, if this pattern of fossil finding continues, how many fossils does Damien have when Dayjoy has 55 fossils? Well, I know that I can simply subtract 55 minus 9, and I know that Damien will have 46 fossils. That's where I'm going to stop for night 1. You still have 3 more questions left, questions 3, 4, and 5. So I want you to go ahead and try those on your own. They all do follow a similar pattern. If you have questions about them, make sure you're bringing them into class to check in throughout the week. And at this point in the video, we'll move on to Tuesday's homework. All right, let's take a look at Tuesday question 1. A radio station plays 12 songs each hour, and they never stop for commercials, news, weather, or traffic reports. Just 12 songs an hour. Write an expression describing how many songs are played by the radio station in H hours. So I know that the radio station plays 12 songs per hour. That means that if we imagine a table, right, where I have hours on one side and songs on the other side, this could be a little more details, but just to estimate, in 1 hour they play 12 songs. In 2 hours they play 24 songs. In 3 hours they play 36 songs. So what this question is asking me is, what about H hours? Any number of hours H. What can I always do? Well, I can see the pattern in the table. Just like I did with addition and subtraction, this time I'm multiplying by 12 every time. And so for H hours, for any number of hours, I can always multiply by 12. And I'm going to write that as 12H. Remember that 12H just means 12 times H. But this is the big kid way to write it. This is the ideal way to write that. 12H. Now take a look at question B. It says, how many songs will be played in an entire day? So 24 hours. Well, I know what my expression is. It's 12H But in this case, I know that H is 24. So I'm simply multiplying 12 times 24. And 12 times 24 will tell me the total number of songs, 288. This is called substitution. I said, I know that H is actually equal to 24, so let me replace it in my equation and actually do the math. C says, how long does it take the radio station to play 60 consecutive songs? Well, 60 consecutive songs, I know that 12 times some number of hours has to get me to 60, right? Because I'm playing 60 songs. And the question is, what does this H have to be? How many hours? Well, I know that 12 times 5 is what equals 60, so it must take 5 hours. Notice how the actual math that's included in solving these problems is not very difficult. It's more so about reading closely and ensuring that we are answering the question that's being asked of us. We'll do one more example for Tuesday. Question 2. A ski area has a high-speed lift that can move 2,400 skiers to the top of the mountain each hour. Write an expression describing how many skiers can be lifted in each hours. So this time we're being asked again to write an expression. So it can always be helpful to think of this in a table, right? If I think about skiers and then time in hours. And I actually might want that table to be flipped. Think about time. And then think about how many skiers. So I know from the problem that in 1 hour, and this should really say time in hours, but, we're just doing some scratch work here. In 1 hour, 2,400 skiers. And so if that's how many I can do in 1 hour, in 2 hours, I'm going to have to double it, right? Because I could do twice as many. And this pattern would continue down the table. Notice that I'm just multiplying the number of hours times 2,400. And so I can write out my expression, my generalization of the pattern here, as 2,400 H, or 2,400 skiers times H, the number of hours. And that means in a question like question B, how many skiers could be moved to the top of the mountain in 14 hours? All I need to do is substitute in 14 for H in my expression. 2,400 times 14, because now it's not H, it's not a mystery number. We know what that mystery number is. 2,400 times 14, 33,600 skiers. And we actually just answered question C, because question C says, how long will it take to move 3,600 skiers to the top of the mountain? Oh, the numbers are a little different. That's my bad. So I know that 2,400 times some H, we don't know what it is going to move 3,600 skiers. Now, I can use inverse operations to find H, because if 2,400 times something equals 3,600, I know that 3,600 divided by 2,400 will give me H. In this case, it's 1.5 hours. So I'm going to stop there for Tuesday. The rest of the problems follow a similar pattern, and you can always rewatch the 2 examples that I did. Make sure that you're taking a look early and often so you can check in with me if you have questions. And we'll go ahead and skip down to Wednesday. So Wednesday's questions are similar to Tuesday's in that they mostly use multiplication and division. But for most of them, there's a small plot twist. Let's take a look at question 1. Compact discs, CDs, cost $12 each at Music Emporium. The The company charges $4.50 for shipping and handling, regardless of how many compact discs are purchased. And question A asks you to create a table of values that shows the relationship between the number of compact discs that Mikey buys and the amount of money that he spends. So I know that one CD is going to cost $12, but it's asking me for the total cost. And so I can't forget that in addition to the $12 that one CD costs, I also need to pay the $4.50 in shipping. And so the cost of one CD, I'm going to write it down here, one CD is going to be $12 for the CD plus the $4.50 in shipping. And so that's going to give me a total cost of $16.50. Now, you might be thinking, well, I can just double that for 2 CDs. But there's a small detail in the problem that's important. The company charges $4.50 for shipping, regardless of how many compact discs are purchased. That means that if you bought 100 CDs, the shipping would still cost $4.50. And so for 2 CDs, I know the CDs are going to be $24, right? I doubled the cost of these CDs, the price of the CDs. But the shipping is not going to change. It's still $4.50. And so the total cost is $28.50. And it's the same thing for 3 CDs, right? We're going to have to spend another $12 in the CDs. So notice how the CD cost is increasing by 12, but the shipping cost is still $4.50. So it's $30.50. And so B asks for the expression. If you know how many CDs Mikey orders, can you determine how much money he spends? Well, yeah, we see the pattern right here in our work for question 1. We know that we're multiplying the number of CDs he buys by 12, right? We saw that here. If he bought 1 CD, it was 12, 2 CDs was 24, 3 CDs was 36. But then we had to add on the shipping of $4.50. Which doesn't change based on how many CDs you buy. And that means that in question C, where we need to use our expression to determine how much money Mikey spent buying 8 CDs, we can multiply 12 times 8 and simply add $4.50. So we have 12 times 8 is 96 plus $4.50. And you know he spends a total amount of $100.50. The questions on Wednesday's homework generally follow this pattern. There's some relationship and some constant, meaning some number that's a flat fee or a value that doesn't change. So my best advice is to read the questions closely, and as always, make sure you're checking in with me as questions come up.